Hello, for today's video lecture, we're going to be talking about internal forces. So up until this point in statics, we have been talking about external forces. These are any forces exerted on one body by some other body. So if it's the interaction between these two bodies, it's an external force. Whenever we have external forces that are exerted on a body, however, internal forces and internal moments must exist within the body to balance out these external forces. So we imagine looking at a beam. These forces over the end, the reaction forces from the supports, those would be external forces. So everything up in the top there is an external force acting on this beam. When we talk about internal forces, imagine cutting the beam at cross-section AA we have right here, and instead we wanted to look at what are the forces that the left half of the beam must be exerting on the right half of the beam to support this. So these internal forces are within the beam, and here we've got an internal force and an internal moment to balance out those external forces that are existing on the right half of the beam. All right, so at any one cross-section, so we look at these per cross-section, we can have up to two types of internal forces and two types of internal moments. So let's talk about the forces first. So imagine we've got a beam, imagine we've cut it, so I've cut off the end here, this is a cross-section, I'm looking at that cross-section. A normal force would exist within the beam, it's going to be perpendicular to your cross-section. So if I've got some force coming out of this cross-section or into this cross-section, that would be a normal force. And then a shear force exists parallel to the cross-section. So any force within the beam that would be going up or going in this axis to the right, all of those exist in the plane of the cross-section. So those are shearing forces. Next up, we've got our internal moments. And so we have two types of internal moments within our beam. A torsional moment will exist if we imagine having our moment vector and it's perpendicular, kind of like our normal force was, that moment would tend to twist the beam, and that is going to be a torsional moment within our beam. If we instead have moments that are in the plane of our cross-section, so either going up or to the right in this case, either of those moments would tend to bend the beam rather than twist it. So those are bending moments within our beam. All right, so how do we determine these internal forces? So we've got two methods really. We can imagine cutting the body at the cross-section and performing an equilibrium analysis of one half of the body. And this is very similar to what we did with method of sections, where we kind of cut it in half and looked at one half. Or we can use a graphical method to determine the normal forces, shearing forces, torsional moments, or bending moments across a range of cross-sections. So we can only look at one force at a time, but this graphical method is nice in that we can look at the normal forces at a range of cross-sections, kind of going from one end of a beam or a cable to another. Same thing with each of those other pieces. All right, so that's all I've got for today's video lecture. Thank you for watching and I hope to see you again.